Okay, so we started our first problem. We just did factor by grouping, which I hope you remember. You just factor the first part, you factor the second part, then you see the common factor, bring it to the front. Then this was a real answer, and that means it's an x-intercept. And then we set this equal to 0 and solved it and got those two imaginary answers. If you left it with a negative under the root, you lose. You can't have a negative under the root. You got to make the I and have your answer have I in it. Okay, so then let's move on to what are we really learning about today? Factoring polynomials using long division. This is one of my most challenging days because right this second, several of you are scared by the word log division because you're not sure exactly how this works. And the good news is you learned long division when you were in like 3rd, maybe 4th grade. And you were really little then. And so if you never really got it, thankfully, do you think you're smarter than a 3rd grader? Yeah. Now you, compared to 3rd grade you, you're a lot smarter. And you will get smarter all the way till you're like 29. Just your brain improves. Even if you just sat in your room, you just get a little bit smarter and a little bit smarter. Some people think it's because you get more and more layers of myelin on your brain. Your brain is kind of gray colored when you're an adult. Did you know when you're a baby that's not gray? There's no myelin. The myelin is sort of like ice on a hockey rink. Do you get without the ice, the puck would be really slow and the skating would not be very fun? But with the ice, which is like the coats of myelin on your brain, the little synapses can fire really fast and information can travel around your brain way faster. That's why some people all of a sudden get like super smart their sophomore year of high school because they just got another coat of myelin. We're not for sure on how all these things work, but we do know that myelin helps. And we do know that it comes at different times for different people. So that these are facts that you can depend on. All right, so my point is that if you were terrible at this before, and you can get good at it right now, because what we're going to be doing is things like this. Dividing polynomials. But if you can't do it with regular numbers first, well, then you're toast. All right, so here's how you do it. Everybody follow me one step at a time because these exact same steps, you guys are talking too much. Those exact same steps are going to be used when they're polynomials. All right, so step 1, you look and see, does 6 go into 20? And it does. And so you put a number up here. How many times does it go in? 6 times 3 is 18. Now notice, I didn't even try to put 6 into 2. 6 doesn't go into 2, so I just kind of ignored that. And I put the 3 over the 0 because that's like over the 20. All right. So 6 times 3 is 18. Notice I did this times this, and I put it here. Can you guys stop talking about every step? Thank you. All right. So now I go 6 times 3 is 18, and now I draw a line here, and then notice I want you to do this differently than you used to. You said in the past you'd say, oh, I subtract 18. No, you changed the sign on the 18. Because in polynomial long division, sometimes those will be negatives in the first place, and you change them to positives. Okay, so you changed the sign of the 18, and then you combine them and you get 2. And that's a good question. You could keep going. You could get decimals for this from now on. But do you think you'll have a decimal polynomial? No, you won't. So instead, you will have a remainder when we're doing polynomials. So you can do these with remainder. So when you first learned this, you probably knew this was 3 remainder 2. Does that ring a bell? All right. So let's make sure you understand what that really means. That really means that 6 times 3 doesn't quite work. You'll need to add the remainder to make it equal 20. Now, could we have done this and gotten a decimal? Yes. Could we have done this and gotten a fraction? Yes. We could have done this with an answer that's a fraction, but we don't want to because we want to do these just like we would with long division of polynomials where they're going to have a remainder. So I know this could have been 3 2/6, which reduced to a 3 1/3. Do you get that this 2 remainder could be made into 2 out of 6? And you could say 3 1/3 here, but do you think you can have a fraction of a polynomial? No. So we just are going to do it with this remainder right here. All right, question.
So you said change the sign, but we're still subtracting.
Yes. Would you agree that 6 times 3 was 18 in the first place?
Yes.
So wasn't it positive 18 to start with?
Yes.
Because 6 times 3 was 18, right? See, when we do the polynomials, sometimes you'll have a negative number on the top. And we have to learn that this is not always subtract. It's change it from whatever it was to the opposite of that. Okay, so in polynomials, it's not always going to be subtract. Sometimes it'll start as negative and you'll change it to positive. All right, so now I want to do one where I don't say anything and you just figure out, do this correctly with the remainder. Just long division of normal numbers. Try this, get it right with the correct remainder. Because if you can't do it with numbers, how on earth are you going to do it when there's variables running around in there? So you put 3 up here, right? So that's the first step. Second step, 7 times 3, 21. Notice it's positive 21 right now. Then I go and change its sign. I know, it seems like subtracting, but trust me. It's better to just say change the sign. And then put them together. And in this case, that leaves us with a 1. So then it's remainder 1. So then the way we write our polynomial answers is like, how do I get 22? 7 times 3 plus the remainder of 1. So it's like you're breaking it into a multiply problem. You're factoring it, but it happens to have a remainder left over, so you have to add that at the end. All right, now I got to see, be honest, how many of you feel like you've got this? Okay, cool. Now it's going to get a little harder because I think you all know that it's weirder if it's like 203. Let's see if you can hang with this one. You'll have to bring something down. 7 goes into 20. Let's see if you remember to bring something down step. We're accessing a part of your brain you probably haven't used for 3 years. Cobwebs on the memories. It only goes in 2 times, and it's 14. Draw the line. I'm going to call this opposite of what it was. Then that brings down a 6. I mean, it's just subtracting at that point. Then you bring down the 3. Remember that? And then you go 7 times what makes 63? 9 makes 63. And in this case, notice opposite of. And then how much is left? 0. There's a remainder of 0. Do you get that I could say there's a remainder of 0, or I could just not even mention it because it's kind of irrelevant? Because there is no remainder. All right. And then do you agree that 7 times 29 is 203? All right. So what did we really do? We really just factored it. Do you get what I mean? We just factored 203. Nobody talked about long division as actually being factoring, but that's really what it is. So, welcome to the polynomial part. X plus 1 goes into, now I'm going to start with an easy one. You know, when you teach a kid how to multiply, you don't start with 74 times 29. You start with something easy. And the kid, even if you were starting with 2 times 3, the kid just could be like 2 plus 2 plus 2. And that makes 6. And they did it by adding, which isn't really what you wanted them to do. But my point, I got to start with an easy one. So just trust that this same process I'm going to teach you will work on the hard ones. x squared minus 2x minus 3. Okay, so it's polynomial long division. Would you agree that all of our other long division problems, we started by putting something on the top? Didn't we? All right. So on this, trust me on this, you're always going to want to start with an x or an x squared or an x to the third. So just start with an x. And again, if that doesn't work, then you might go, oh, maybe I should start with x squared. Okay, in this case, just an x. Now, what did we do next? We always multiplied this times this. But there's two parts to it. So it's kind of like distribute. We got to multiply by both parts. X times the x makes x squared. X times the plus 1 makes plus 1x, or just x, but I think it's actually smart to put the 1 in front on this case. Then do you remember that you always drew a line right here? And you always did, this is the most forgotten step right here. You always went through and made it the opposite. Now, do you think we should just put a negative on the first one? No, we probably have to put a negative on both of them. Change them to the opposite sign than they were. Now, the way you can tell you're doing it right is if these two match. If these two don't cancel each other out, you're doing something wrong. So when I put those together, they are opposites of each other, so they're gone. And then this part is what's really going to be left. What is negative 2x and negative 1x when I put them together? I don't like to think of this as add or subtract. Thinking of it as put them together. Would you agree it's negative 3x? Awesome. Then what did we do when we wanted to get the next number down? Yes, you just brought it down. Okay, and then what did we do next? We go back up here and we put something up on the top. All I can tell you is what you always start with is x. But after that, what you put here really depends. Like, I don't know. I think it's probably just going to be a number. But remember, I want to put something up here so that when I do multiply it, like I did the other one, it'll come out exactly to negative 3x. I want to match it exactly. So I think I should put a negative 3 right there so that negative 3 times the x makes negative 3x. And I know some of you are like, but don't you want to like make them opposites? Yeah, we'll do that in a minute. For right now, we just make them exactly the same. And now the negative 3 needs to times by the 1, and that makes negative 3. And you might be like, oh, sweet, they're all going to cancel. Careful, follow all the steps. Draw the line, opposite, opposite. And now, when you combine them, then they actually do all disappear, and do you get I have a remainder of 0? And if I have a remainder of 0, I don't even have to talk about it. It's just not there. And then really what happens is this times this, you just factored the black x squared minus 2x minus 3. You just factored it. That's what you just did. You just factored it. Now you might be like, I could have factored that in my head way faster. You're right. But we can use the same process to factor things that have 7 terms. You would never be able to do that in your head. You can't even factor it by grouping because there's 7 terms or 5 terms. All right, so trust me that this process is going to work even when these get to be gigantic, and that's what it's going to end up as. And the test is on Friday. Okay, so this is the first day of long division. We do a little more with long division. We add something else to it tomorrow. Wednesday, there's only one more thing, and then we start reviewing. Thursday, we review a little bit more. Friday's the test. Okay. Big test coming up. Hardest test you've ever had in this class. Because it's just got so many topics, one of which is really hard factoring. All right, so here we go. Everybody try this one, please. We're going to actually go to this problem. This is page 3 of your notes. So let's read this. So now you can factor polynomials with 4 terms. What about factoring problems with 5, 6, or 7 terms? Like this one. We need a new strategy, polynomial long division. Now, to start with, we'll always tell you what to divide. All right? So like this part right here would go underneath the big long, and it looks like a square root thing. It's not. It's a long division bar. And that is called the dividend. The way I remember it is the dividend is in the den. It's like a bear climbs into the cave, you know, to sleep out the winter. This is the dividend in the den. And then the divisor goes on the outside. Like let's say I said x. Let me think if I can do this one in my head. There's a way to do this, which I will teach you later, to figure out what number goes into it. All you can do is get best guesses of what goes into it. And I think 2 goes into it. So then I go x minus 2. Remember, if I think the number 2 goes into it, then the factor for that would be x minus 2, and it would go out here. Now, this one's too hard. You guys aren't good enough at this yet. Some of you could probably handle it, but we're talking like 2 of you. So let's move on to the next page. I just wanted to show you the big picture. So this is just reminding you, like, this is based on regular numbers. Is 7 a factor of 83? Well, everybody set that up. 7, 83. I know some of you doing your 7th table. 7 times 6 is 42. 7 times 7 is 49. 7 times 10 is 70. 7 times 11 is 77. 7 times, let's add 77 plus another 7. That'd be 84. Oh, it was really close. So, everybody please solve this one. Just a reminder of how normal long division works. Does 7 go into 8? Yeah, it does. Nikita, what do I put here?
Oh, you put a 1.
Yep. Take it from there. Keep on going.
And then you put a 7 under the 8.
Nice. Now what?
And then you do the opposite.
I love how you said that. Don't say subtract. Say do the opposite of. Because sometimes it won't be subtract. In the middle of our other problems, this could be negative. And we might have to add 2 negatives, which is not subtracting. So the way you should say it is, now you do the opposite and combine them. And then that does become 1, and this drops down, becomes a 3. And then does 7 go into 13? No, not exactly, but 7 times 2 is 14, but that's too much. So I guess we got to go with 1 again. 1 times 7, 7. Change it to the opposite of. Subtract, get 6. I guess this one has a remainder of 6. 11 remainder 6. Which means that 7 times 11 plus 6 would equal 83. Okay, so dividend is in the den. Divisors on the outside, they're both D words, and divide is a D word too, so that all kind of works. And then did you know that quotient is what you get when you divide 2 things? It's called the quotient. All right. I don't think we need to do another one with just normal numbers. Let's go on to this page. Would you please set up and do this long division? Research shows that I should let you try it before I just tell you the answer. Now that I've showed you how to do it. Okay, let's see how you did. X minus 1 goes into x squared plus 2x minus 3. First thing I told you is always start at the top and put an x there and see if it works. How do I know if it works? I multiply it by this, and I see if that lead term drops out. X times x is x squared. X times -1 is -1x. Now remember me saying that sometimes there'd be a negative number, and so this is changing it to the opposite and the opposite. Did some of you mess that up? Notice it's -x squared and plus 1x, because I went through and made it the opposite of what it was. Now these two do drop out, so I can put a 0 here, but I don't even really have to. I could just have nothing there. And this makes 3x. Then you go back up to the top, and this time I said you'll have to like think about what to put there. And I think you should put a +3. Common mistake is to put a -3 there. No. You want to match it exactly so that the 3 times the x makes 3x. Later, we'll make it the opposite. 3 times the -1, -3. Oh, wait, I didn't bring this down properly. Should be -3 there. So then when I go 3 times the -1, it makes -3. Draw the line, and this is the opposite part. And now those do all cancel out. I got a 0 remainder, and sweet, I have factored it. And the factors are located here and here. And I know you could have factored that an easier way, but you're learning how to do it step by step so that when we hit you with a 5-part term, you'll be able to still use this process to factor that. All right, moving on to this one. This one's a 4-parter. And the cool thing is you wouldn't have been able to factor by grouping. Look at it for a second. Do you get that this isn't going to even factor? And this, I guess you could factor out an x, but it would not work to factor by grouping. But this new way I just showed you, it'll work. X plus 2 goes here. I know it takes a second to write these out. But there, I'm done. And I'm old and slow. You should be able to do that. Then how do you start? I always said to start with an x, but that you might have to adjust. Because look, x times x makes x squared. Is the first term going to drop out if I do it that way? No. So then are you smart enough to know it would have been x squared? And oh, wait, even smarter, 3x squared? Who beat me to that? And you already had that. Sweet. Yeah, it's 3x squared up there so that I can get 3x to the third when I multiply it. And now the 3x squared gets times by the 2, and that makes plus 6x squared. Now follow a system. Those of you that are careful, math rewards careful people. You just do one little step at a time. Put those together, 7x squared. Bring down the next term. Not both things, just one thing. Plus 10x. And now you figure out what to put up here. See if you can finish this thing. I'm going to pause for a sec. See if you can finish it. Okay, let's see how you did. At this moment, you look at this and you go, oh, 7x squared, I got to match that. So then you get smarter and smarter about these and go, okay, I need to make it 7x so that when I go this times this, I get 7x squared. Exactly match it. 7x times the 2 doesn't have to match. That's going to be a 14x. Most common mistake right here is you forget to do opposite and opposite. That means that this is not 24x. If you did that, you screwed up a negative. You forgot to make it the opposite. It was -4x. Then you bring down the -1. And then I'm going to put a number here. Got to match exactly the -4x. So I put a -4 here. -4 times the x, -4x. -4 times the 2, -8. And if you feel like it's getting all messed up, well, that'd be the part where you check with the kid next to you and say, did you get a remainder? Because I got a remainder. Opposite, opposite. These two cancel. -1 plus 8 is 7. So there was a 7 remainder. Raise your hand if you had a 7 remainder also. Awesome. Then for extra bonus points, did anybody actually write out the final answer, which is x plus 2 times 3x squared plus 7x minus 4 plus the remainder? There is your final answer. It's kind of factored. It's factored most of the way, but there was a remainder of 7. Make sense to you? Cool. Then there's only one more thing. The problems just get more and more complicated. But I think you got the process down. You should know what goes in the front. You should know what the part is the dividend and goes in the den. Set it up. Try it with no other help from me. I'll pause for a second. And you know what you can do at the end that really makes it easy? If you end up without a remainder, you pretty much know you did it right. The odds of you coming up with no remainder by accident is like infinitesimal. So if you get a remainder of like 6, you could turn to the kid next to you. Did you get a remainder of 6? And if you both got a remainder of 6, the odds of you both getting the exact same wrong remainder, also infinitesimal. So just see if you got no remainder, you probably did it right. If you got a remainder, see if the kid next to you got a remainder. That's how you can know. All right, I'll pause for a sec. Give this one a try. I know that you may not be done, but just hurry up. I'm going to start slowly explaining the problem, but most of you are past this. Just keep working. Maybe occasionally look up and see if I'm getting the same thing as you, but try to finish while I'm just starting here. Oh my gosh, they both dropped out. Whatever shall I do? Bring down both of these things then. So then I need to match it exactly. I need to match 2x, so I need to put a plus 2 here. Always match it exactly. 2 times x, 2x. 2 times negative 5, negative 10. Then do the opposite. And cool, it all seemed to drop out. And there's my answer. Remember to write the answer as factoring. That's the point of this. We factored it. Now this one could have been done by grouping. But on the test, we are allowed to tell you how you have to do it. And we could say, show by long division how you'd factor this. But just awesome if anybody noticed, you could have factored the first part, factored the second part, and then it would have turned into factor by grouping. All right, next page. This, I don't even want to do the whole thing. I just want to set it up. Everybody knows which one goes in the den, the dividend, the 2x to the 4th. Everybody do that. You're just basically copying it into the dividend spot. But the harder part is, what the heck do you do with the 2? Don't say it. Some kids heard me say it earlier, and they're going to know what to do. If you don't know what to do with the 2, ask the kid next to you. I'm going to pause, think about it, and then compare answers. Okay, did you know that you should put an x minus 2 right there? Remember, if this is the solution, it's also the 0, which means 2 should make your factor equal 0. That's why we don't put x plus 2, we put x minus 2, because 2 is supposed to be the thing that makes it equal 0. All right, then from there, at least, how would you start it? You'd go, want to match this exactly, so x alone wouldn't be enough. That'd just be x squared. Oh yeah, x to the 3rd would make it x to the 4th, and then a 2. Raise your hand if you knew. We'd start with 2x to the 3rd. Okay, awesome. Then we're not even going to finish that one. I think you've got the idea. All right. Missing terms. That means you set this all up, everybody do it, 2x minus 5 goes on the outside, and 2x to the third minus 9x squared, and then wouldn't there be a regular x term right next, and then you'd have 15? Word to the wise. I screwed up something here. This is a 3, sorry, hold on. There we go. Word to the wise. If it's going x to the third, x to the second, then it should be doing an x to the first right there. It'd be really smart to put a placeholder in and go plus 0 x to the first. Now, you don't have to do that, but if you don't do that, weird things are going to happen when terms don't line up nicely. So do you get that you can put in 0x to the 1 power? I mean, it's really not there, but it's holding a spot, and it'll keep everything lined up nice. All right, Keenan, tell me how to start. We're going to put a number on top.
Put x squared on top?
X squared. And then does it match exactly if you put an x squared here? Well, what do you get, Mr. Keenan?
2x to the third?
Yeah, it does seem to match exactly. So then that's how you knew you did it right. Good. And then this times this, negative 5x squared. Draw the line. Opposite, opposite. Most forgotten step. Together that makes negative 4x squared. Bring this 0x down. Trust me, it's there for a reason. Then you put a number up here that makes it work, meaning it matches exactly right here. So I need a negative 2x, I think. Now I'll try it. Negative 2x times 2x makes negative 4x squared. I made it exactly match. And negative 2x times negative 5, this is this times this, makes positive 10x. Draw the line. Opposite, opposite. The first two cancel just like they're supposed to. You know, these terms cancel. That leaves us with negative 10x right here. And that's where if there hadn't been a 0x, it would have got really confusing. If you want to do it the other way, it actually can work. But I think your life's a lot easier if you put in a missing term as a 0. Okay, now I'm adding 15 here, and then I draw the line. Oh, wait, no. Then I put something up here. And I want it to exactly match this. So negative 10. So I need a negative 5. Negative 5 times the 2x makes negative 10x. Negative 5 times the negative 5 makes positive 25. Draw the line. Opposite, opposite. There was a negative 10 remainder. Did anybody else get a negative 10 remainder? Quite a few people. Cool. So then if the question is, did this factor? No, because you'd take this times this, but you got to add negative 10 at the end. So the question was, is that a factor of it? No, it didn't come out perfect. Just like if you had 7 goes into 9. Does 7 go into 9? Well, kind of. 7 times 1 is 7, and then you subtract it, and then you make 2, and then you got a remainder of 2. So does 7 go into 9? Well, you could say 7 times 1 plus 2, but that really isn't a factor then, is it? Because there's a remainder. So no, it didn't go in. Just like 7 is not a factor of 9. Just because you got two things, this and this, doesn't mean it worked because there was a remainder. All right. Now, stop. You obviously know you have homework. Would you like to know which problems you could skip?
Yep.
All right. I am going to simply have you do the even problems on tonight's homework. Do the evens. Just the evens, but do them. If you take tonight off, you really messed up because this was a hard day You need to practice it, just do the evens. Have a great day.
Questions.
There are only 5 minutes of